Now we are going to discuss about the types of unsupervised learning. Unsupervised learning has been majorly classified into two types, and the first is clustering and the second type is association. These are the two types in which unsupervised learning is being classified. Now, clustering is a type of unsupervised learning where you find certain patterns of data that are you working on. Now, it could be several patterns such as shape, size, color, etc., which can be used to group the data items. So this is about clustering. I'm going to show you an example, a very basic example of clustering also. Here you can see that I have made several dots of color, and such as this is of red, this is of blue, and this is of orange. Now, while identification, this can be said as group 1. This blue one can be said as group 2, and this orange one can be said as group 3. So what we have done, we have made several clusters, or let's say patterns, where we can identify the data, and here we have done on the basis of color. Similarly, if I draw certain patterns, let's say circle, triangle, rectangle, and if then the clusters are made, then they will be said as clustering on the basis of shape. Now, clustering is further divided, or it has several algorithms in it, which we are going to discuss in brief here, and we will discuss broadly also when we will do certain example. So the very first type is hierarchical clustering. Now in hierarchical clustering, the algorithm builds cluster on the basis of similarity between the different data points. So it operates on similarity. So hierarchical operates on the similarity of the different points of data set. It goes over the various features of data point and looks for the similarity between them. Just like we did here, it goes over various data points and checks for the similarity. If data are found to be similar, then they are grouped together. As here you can see, grouping is done. Now this continues until the data set has been grouped, which creates a hierarchy of these clusters. The next type which we have is k-mean. In the k-mean clustering, these algorithms work on step by step, where the main goal is to achieve cluster which has labels to identify them. That means it has certain labels, and also it calculates the centroid of the cluster and the basis of distance in between them. For example, now here I am drawing several clusters. Now what it checks for the centroid. Let's say if this is one point we are checking and this is the another point we are checking. Now if we want to check the distance between these 2 points of this particular point, this one, this red dot. So this distance will be d1, and distance from this centroid, so this is centroid c1 and this is centroid c2. So this particular distance will be d2. Now what it does the smallest distance between the data point and the centroid determines which cluster it's belong to, while making sure that cluster do not interlay with each other. So what it does, it has a tabular form, let's say C1 and C2 clusters, and there can be different data points, let's say D1, D2, D3, all can be the data points. Now the distances, so it can be D1, D dash. So this centroid respect to data point D1, the distance is calculated. Similarly for D double dash, displaying the distance with the C2 centroid, and rest of the data points like that. So the smallest distance is taken to be the centroid, which determines the cluster where it belongs to. So it will do the clustering like this. The C1 comes with this, and similarly it checks several data points with the respective cluster. That is the k-means clustering. Now here we left association. So association is a kind of unsupervised learning where you find dependency, where you find certain dependencies of one data item with another data item, and then map such them in ways you help to the profit better. Some popular algorithms in association rule mining we will discuss now, but if you want to say like that in basic terms, if X, then only it implies to Y. So if X will be there, then only Y will be there. In the very basic example, you can say that if I went to a market and if I buy the bread, so the bread influences the buyer to buy milk and eggs. So it depends. That means it dissociates the association, where dependency happens between the data set. Now we're going to discuss two basic algorithms in brief, and then we will do it with the examples also. So the very first is FP growth. Now what is this FP growth actually is? This is also known as frequency pattern. So the frequency pattern algorithms finds the count of the pattern that has been repeated. What it does, it checks the count of pattern. As the counts of the pattern are repeated, then it adds them to a table and then finds the most possible item and set that as the root of a particular T. For example, if you say like that this is the root and these are the several nodes. And again it is further classified in nodes. So it counts the frequency of the pattern. Let's say if this is further more elaborated, it counts and then it actually calculates that which items are needed for the support. This is a much faster algorithm, and here support is calculated and checked on increasing number of iterations. So it is checked on the basis of increasing number of iterations. Next we are going to study about one more algorithm, that is a priori. Now in this a priori algorithm, what happens is that it is a breadth first search based, which calculates the support between the items. This support basically maps the dependency with one data item with the another, and which can help us to understand that which data item influences the possibility of something happening with the other data item, which we have given in the example of bread and the buyer of milk and eggs. So the mapping helps to increase the profit of the store. If such kind of mapping is done, then it will help us to increase the profit of store. And this sort of mapping can be learnt using this algorithm, which yields the roots for its respective output. We will discuss about them in brief when we will be doing certain examples, so no need to worry about it now. Lastly, we are going to discuss about several applications of unsupervised learning. That where are these applications, or where are this unsupervised learning so much in use? As we studied about unsupervised learning, what it helps us to do, it helps us to understand several patterns. So while it helps us to understand several patterns, it is used to help the clustering of data also, such as we can say in online shopping sites. What it does, it actually shows the user or certain kind of recommendation which you have already purchased. That means the customer purchase, depending on the sort of the tendency of customer which he or she needs to purchase the product more frequently, are grouped together. So that actually done on the basis of association rule mining only, where dependency can be shown. Similarly also in credit card fraud detection. Now in credit card fraud detection, what it does is that we know that the partners or the several things are actually doing such fraud things. In unsupervised learning algorithms, we learn about various patterns of the user and their usage of credit card. If the card is used in part that do not matches the behavior, an alarm is generated which could possibly be marked as fraud, and calls are given to confirm you that whether you are using this particular card or not. So that also helps there. Also, cleansing of data sets by removing features which are not really required to the machine to learn from them. So that is also done with the help of unsupervised. When the patterns is matched, it is itself learning how to determine that pattern. So it can automatically clean the particular data set which are not required. So these are the several applications of unsupervised machine learning, and we will be discussing about the algorithms which we have studied in deep, and we will be doing several examples. Next, we will discuss about the advantages and disadvantages of unsupervised machine learning in our upcoming video.